The next speaker is Chris Salzberg. The title is The Ruby Module Builder Pattern.
Hi, everybody. My name is Chris Salzberg. So my talk's about module builders. What are the odds that Matt's the creator of Ruby gets to talk about modules right before mine? So I'm pretty happy about that. I'm a writer, a programmer, translator, and I'm known as, I use the handle Shioyama. I have this gem called Mobility that I'm going to talk a bit about. I work at a company called Degica. Here. We have a booth in the sponsor area, so come talk to us if you're interested. We're hiring. We're based in Tokyo. Okay, so first what I'm going to do is I'm going to give a bit of introduction. So this is kind of the blog post that was the starting point for this talk. It's a blog post that I wrote on my blog a few months ago. It's about modules. And it's kind of got some slightly heavy kind of Ruby, pretty heavy Ruby stuff in it. I didn't intend it originally to be a really long thing, but it ended up being a really long article. And it was about stuff that I was working on this gem called Mobility. And so I took about a month to write it. It was really long, and I posted it, and I expected kind of the Ruby diehards to kind of find it interesting. But actually, it got picked up on Hacker News and some other places, and it ended up getting about 30 or 40,000 views, which surprised me because it was kind of heavy. So I saw that, and I said, okay, this is maybe an interesting talk to take further, and so I proposed it to Ruby Kaigi. And what I'm going to do today, I'm going to take a little bit of a risk here, and instead of just jumping into the blog post, which is a lot of Ruby, I'm going to try to take a few steps back and think about modules more generally. And I think it's kind of good because Matt's kind of set the stage with this whole talk about modules. So what I want to do is I want to kind of think about modules apart from programming and apart from Ruby, and then see, how much do Ruby modules match with that idea. So we have this idea called module, right? And I think programmers, we kind of have like warm and fuzzy feelings about this thing. Does anybody hate modules, right? Nobody hates modules. But like, what the heck is a module anyway? So here's one definition. I think it's from Wiktionary or something. But a module is a self-contained component of a system, often interchangeable, which has a well-defined interface to the other components. So this is kind of a good definition to start from. And the two things that I want to point to here is the self-contained part and the well-defined interface part. Those are going to be kind of important. So if you think about module, right, try to take Ruby out of your mind and just think, what is an image of a module, right? So I did a lot of Google image searching before this talk. I did probably way too much, looking for like, what's a module? So this was kind of the thing that, to me, gave me the most feeling of like module. And what's modular about it? Well, you can see that it's got this interface, right? It's got a few interfaces all around it. And those obviously allow it to connect to other modular things. It's also self-contained, right? The implementation of this thing is mostly inside. You can see some stuff sticking out of it, but this is actually a Russian space module. I know nothing about space science, so. So what happens when you have lots of modules and you connect them together? So this actually is a really interesting building. My dad's a architecture professor, so the first time he came to Japan in Tokyo, the first thing he went to was to see this thing. It's called Nakagin Tower. Maybe Japanese know it more than foreigners, but it's a really interesting building. It was built in the 70s by this Japanese architect. And the idea is that you can take these things out and you can replace them. So they're very modular, right? And so so you can take them out. So they're again, it's very self-contained. You got a self-contained living unit inside each of these things, and it's got an interface. And the interface on these things, surprisingly, is 4 screws. And that's it. So a bit scary. But then there's another modular thing. This is a motherboard. This is actually for a Sony PlayStation. And you can see in this case, we're getting a bit closer to the idea of programming modules here. You've got lots of different types of modules. Each of them has different interfaces. And they're all obviously self-contained. If they weren't self-contained and they were spread out all over the motherboard, you wouldn't be able to get a game console out of this. So the idea of modular design is kind of, this is a quote from Wikipedia, but it's kind of an attempt to combine the advantages of two things. The first one is standardization, right, which is on the left side. This is sort of the idea that you have one template and you just mass produce it. And that's really cheap, so that's cool. In programming terms, this saves us programmer time. On the right side, we have customization. These are snowflakes, so each one is different. We can do whatever we want, but it's really costly. And so modular design is about kind of carving out things that we can template in this space and then connecting them together in different ways to get some level of customization. So what are the elements of modular design? Well, the way I think about it the first thing is you have to have an abstraction. So you take that idea. So whether that's a living unit or a memory in the motherboard, you have some common pattern, and then you define a specification for it. This is like the interface for it, right? And it's got to be some well-defined interface. And then you encapsulate it. And this third point is really important, and I think it's sometimes looked over a little bit. But you wrap this thing up, and you have to wrap it up because behind a public interface, because if you don't do that and you want to use this module in lots of different contexts, you're going to have collisions with other things. So I call this the scaling rule. This is kind of my thinking about this, but the broader you want to make your abstraction, the more different contexts you want to use your module in, you're going to have a broader abstraction, right? This is a good thing, obviously, because it's like the don't repeat yourself principle. You want to be able to use your module in as many different contexts as possible. But to do that, your specification is going to have to be really expressive. You're going to have to be able to handle lots of different types of interfaces. And at the same time, you're going to have to make your encapsulation tighter because you're going to use this thing in lots of different places. You don't know what kind of collisions you might get out of it. Okay, so that's the end of my sort of non-Ruby preamble here. Now into Ruby, and Matt's already talked about a lot of this stuff, but modularity, what do we have in Ruby in terms of modularity? Well, modularity is, actually, you can look at modularity in lots of different ways, but the obvious sense is, obviously the first thing we have is this keyword module. And this is modularity through inclusion. So actually, I put here a collection of methods and constants. Matt's pointed out that you can also use modules for namespacing, so that's another thing that modules do for you. And they have a callback method, so this is the included callback method. And then there's also modularity through inheritance. We don't think of this as modularity because we have this module keyword, but actually it is also, you're also reusing things. So you can subclass, and then again, you can share methods and constants. And again, you have a callback method. In this case, it's the callback method inherited. But I mean, in another sense, gems are also modules. And the gem installed Educa there, if you have a console opener, just try that. It's a little text adventure we made. But again, so gems are modules in the sense that they're self-contained. They have a collection of classes, modules, objects, and other code. And they have an interface, the dependencies, and also all the interfaces to all the objects in it. And the key point here is that these gems are as flexible as their components will allow them to be. And so the starting point for me thinking about modules was this gem that I'm working on called mobility. And I'm not going to get into details about the gem because it's a bit of a digression from this talk, but it's a gem for storing translations in the database. And the point about abstraction is important for this gem because there are a lot of translation gems out there, and they each store your translations in one format or another. Either maybe it's a JSON B column or as another column on another table. And so this gem kind of abstracts those all the way into this idea of backend. And so basically it does what 5 or 10 other gems do in one gem. And so to do that, it has to abstract these storage strategies into these things called backends. And then it supports this flexible collection of plugins. And these plugins are built a lot on this module builder that I'm going to talk about. So this was kind of the motivation for me to get into this idea. So this is where we're starting from, right? This is the Ruby module Matt's talked about. And there are lots of great things about modules, so I'm not going to trash. I'm going to start trashing modules, but modules are great. Don't get me wrong. But here's like really basic, right? I got my method foo, I got my class A, I include module, and then I can override it, and I can do this method composition here. So that's fine, right? But are modules flexible? And this is kind of pseudocode. This is not real. This is not going to work. But what I kind of want to get people thinking about is, what if I want to use this module in different contexts, and I want to kind of pass some kind of configuration into it, and then let it be kind of a template that does different things in different, depending on the configuration, right? And of course, if you do this, I mean, in the top one, it's going to fail in the first line because that's a syntax error. And then if you try to actually include something like that, it's going to treat it like a method, and it's not going to work either. So this obviously doesn't work. And the other point is, are modules encapsulated? And well, at least in this sense, they're not, right? So if you have a module and then you define a private method bar, and then you include this module in a class, I mean, if this is really encapsulated, that private method should not be accessible because that would be encapsulation. But actually, that's not the case. So if you include my module and then you define bar, it's going to override the original bar, and you're going to get foo_baz instead of foo_bar. Actually, the interesting thing here is actually what the module is doing, and this is actually what Mats was talking about. It's kind of actually doing multiple inheritance. It's not really a module in the sense that we've been talking about so far. But in any case, the result is that depending on how you use modules, if you're not careful about it, if you have modules with like lots of private methods in them and you just include them, you're getting all those methods in the classes that you included, right? So you can end up with this kind of mess. And so what do we do? right? As Rubyists, how do we solve this problem? So as with many problems, we reach for metaprogramming. And I love metaprogramming, so don't get me wrong. This is actually code from Devise, and I love Devise too. I'm not trashing Devise, but I challenge you to read this code and tell me what it's doing. I'll give you 5 minutes for that. So what it's actually doing in a broad sense is they want to configure something in a module, but you can't do that. So what they do is that you shove the configuration somewhere else into a class or something, right? That's kind of roughly what it's doing. And I kind of saw this because we were working something at work, and I just kind of sparked my eye because I was kind of curious, and then I dug into it. So I think this is unfortunate because actually what I'm going to talk about is there's a better way to do this actually. So now I'm going to jump into the stuff that's in the blog post. I'm building with modules. First I'm going to give you some background on how people do this now. So I'm going to start with, this is the example from the blog post. It's a little module called Addable. It's just a module that allows you to add things on classes that have pairwise kind of coordinates. So you have method plus, it takes a thing called point, and then it creates a new instance of itself where it adds the x of the point with your own x and the point x of y of the point with your own y. So it's like coordinates, right? So I have a class point, which is a struct with x and y. I include Addable in there. And then, I should use this pointer. And then I get a point 2 plus 2, 3, and I end up with 3, 5. So it's working. So that's pretty simple for everybody. That's okay? Okay, so this is the example that we're going to use throughout this, basically most of this talk. The other part of this example is that I want to now define another method called plus, or redefine plus here inside the class, and then I want to log my additions. So I'm going to call super, and super is going to go back up to this Addable super. And so I'm going to put out enter adder, and then I'm going to super into the parent, and that's going to do the actual addition. And then I'm going to output the exit adder. So you can see if I do p1 plus p2, now I get the same result, but I get the enter adder and exit adder right there. So I hope that's sort of straightforward for everybody. Is that cool? Because this is going to become like that's basically it as far as the example we're going to look at for the rest of the talk. Okay, so what's the problem? The problem is like this module is really limited. Any class that wants to include it and use it, it's going to have accessors x and y. That's going to make it pretty darn limited in what it can do. So this is the whole thing about specification that I brought up earlier, right? Making that expressive or flexible. At this point, this module is not very flexible at all. So the question is, can we abstract this module so that it defines addition on any set of accessors? So accessors with any names. And can we do that in a way that supports method composition? So the first way we're going to do this, I'm going to use a term called bootstrap methods. So this is a little, so the this middle part here, I mean, don't worry too much about the splat. I don't know if people know what splat is, but basically what I'm doing is I'm abstracting this idea into addition over any number of attributes on a class, or any number of accessors on a class. But the main point here is that what we're doing is we're defining a method now, okay? The method's called define adder, and it takes some set of keys. And then inside the method, we're defining this plus method now, right? So we're doing a bit of metaprogramming here. And inside this plus method, we're doing basically exactly what we were doing before. The only difference is that we're kind of generalizing it for any number of coordinates. Okay, so I'm going to call these bootstrap methods for reasons that'll be clear. So we're going to bootstrap this method now. So I'm taking a new class now, right? So now instead of being the class point, it's a class line item. But it's also got two accessors. And now they're called amount and tax. So if you put the previous module in here, it won't work, obviously, because the previous module uses x and y, so it's not going to work. But now what we do is instead of including, right, we extend this define adder thing. We extend it because we want the class method, not the instance method. So we get this class method, we get define adder, and then we call define adder with amount and tax. And what that gives us is it gives us basically this. And this is exactly the same as the first Addable module, except that now instead of x plus other x and y plus other y, we have amount plus other amount plus tax plus other tax. So we've got that flexibility, right? And if you try it out, it works. So I can add line items. I can add anything now. I can just extend adder definer and define my adder with any set of attributes, and it'll define this plus method. But now the second part of that problem was that I want to be able to compose stuff. So I do the same thing. I include the, I extend the adder definer, define adder. Now I put this other method plus in there, right? With the logging code. And then I try to add them. So I hope maybe a lot of people know what's going to happen here. But basically you're going to get an exception. And it's going to say, I don't know what that superclass is for that method plus, because I don't know what that plus is. And why does that happen? Well, it's kind of obvious if you expand out what's actually happening here. You're defining plus first from these define adder, and then then below that, you're now defining it again. And a class can only have one method with one name. So that's not going to work. The last one's going to clobber with the first one, it'll lose the original one, and so it's going to say, I don't know what to super into, and that's going to fail. So that doesn't work. So next try. We're going to do 3 tries at this. This is now the 3rd try. Defining methods directly on the extending class is not going to work very well because we can't compose them now. So what we're going to do instead, we're going to define methods on a module which is included into the extending class. So here's what it looks like. So the key point here, this is all exactly the same. So that's the same. We're going to keep reusing the same method. So don't worry about what's in there. That's just defining addition on like we had before. The key difference here now is that we're creating this anonymous module. So I don't know, how many people know what anonymous modules are? Nobody? Okay, so some people do. Anyway, yeah, so we're creating a module. It's called an anonymous module. It's used a lot of places. So this is especially in GEMS. So you're creating an anonymous module, and then on this anonymous module, you're defining a plus method, and then you're including that anonymous module. So what does that do? Why would we want to do that, right? So I'm going to expand this out now. So previously we just defined the method twice and then we clobbered the first one, so that didn't work. But now what we're doing is we're kind of creating dynamically a method, and then we're defining a method, we're dynamically creating a module, and then we're defining the method inside that module. And then we're including the module. And the key thing about this is that because it's now in a module, when you call super out of plus, when you define it on the class, it won't clobber because it's not on the class. The other plus is not on the class. It's on an ancestor. And so if you look in the ancestors of line item, you see that module right there. So you see it there, right? That's the module that I've created. This is called an anonymous module, and it's useful. It's really useful for these kind of situations. And now it works. So now you can extend adder includer. You can define your adder, and then you can, if you want to, you can define a method that overrides it in your class, and you can super into it, and that'll work. And you won't get any no method error. And actually this method is really widely used. So if you open up Rails, for example, and you look around, you'll see that this idea is used. And this is an example here. This is actually in attribute methods, active model attribute methods. And you can see that what they're doing here is they're creating an anonymous module. So you have module new tap, and then tap is used. So then you take the module here and you just include it. And so what's the point of that is that you're including this anonymous module, and then you're assigning it to you're actually assigning it to a class variable here. And that way later on you can define methods on this thing, and those methods will be overridable in the class. So for Rails that's really important, because if you just define those methods dynamically right on the class, then if anybody tries to override those ones in their own classes, they'll clobber them. So that's not a solution. So this is used in a lot of places. So just to recap, we looked at 3 different things. The first one was just a regular module with a plus method, x and y. The second one was the adder definer, and that was where we had this class method. We extended this thing, and then we defined it plus on a configurable set of variables. The third one was this adder includer, and this one was the kind of the same, very similar define adder, but instead we created an anonymous module, and then we included that one, and that allowed us to do composition. Okay, so in the blog post that I wrote there, I kind of go into more detail. I'm not going to do that here because it's going to be too difficult, but I look at that example of attribute methods from Rails, or from active model. And I kind of look at how they actually do it. And what happens actually is you have a class, and then you extend some module, and then in the module that you're extending, you define some method. That's the bootstrap method I talked about. And then from that bootstrap method, you call the bootstrap method. Then now you create an anonymous module, which you then include, which has your instance methods. And then on top of that, in our adder, we didn't have this, but in the case of attribute methods, you have also state. You want to have some state. So this is for the prefixes. If you ever used attribute methods, you can have prefixes and suffixes on your methods, and you have to store those things somewhere. So you need some state. And so you put the state now on the class. So the class is state. So you've got your module, but it's, my question is this really modular? Because you got your stuff all over the place. You got your class method in this extended module, you got your instance method in some other module, and you got your class in the actual, the state in the actual class. So I don't think this is modular. And I think it's a better way to do this. So this is when we come to this idea of a module builder. So this is a diagram from a book called Metaprogramming Ruby, which is a great book. I highly recommend it. It's really interesting. And this is kind of the core object model in Ruby. And you got your object class, you got your class, and then you got a subclass. You got a my class, which is a class, and then you got instance as a class. And you've got all these arrows pointing, right? And the arrows are pointing to two things. They're pointing to the class of each thing, and then they're pointing to the superclass of each thing. And what's really interesting, actually, when I was preparing for this talk, I found this image and I wanted to use it, and then I noticed that it's missing an arrow. Okay, it's missing this arrow. And this is actually a really important arrow. This is saying that capital M module, the class of capital M module is class. So the module is a class. So why is that important? So module is a class. Now, this may sound like I'm contradicting Mats, because Mats actually said module is not a class in his talk. He said that, I think, almost verbatim. But the difference is the capital M and the small m. So small m module is not a class. And a small m module can't do things that are like a class. But a big M module is a class. So if it's a class can have subclasses. So I'm going to go through step by step. These are all not surprising things, actually. So capital M module is a class. A class can have subclasses. Now, subclasses can define methods of their own. So they can define a method initialize. And here I'm defining a method initialize, which takes a method name. Now, this is also not surprising. If you think about it, modules can also define methods, right? That's what we do with modules. You say module foo, and then you define some methods inside the module. The thing that's a little tricky here is that inside this initialize method, I'm initializing something that's a module. So in initializer, I am a module, so I can define methods in there. So although it looks really kind of strange properly to most people, this is actually all these four things. These are not strange things on their own. It's just that we never combine them in this way. And this is module builder. Okay, so this is my talk's kind of over in a way. This is kind of the whole thing. But the point is that I think people won't really grasp what's going on here. So I can come back to the slide after if people don't quite get this. But so this is a class in this gem that I'm building, mobility, and it's a class called attributes, and its subclass is module. So this is kind of what you do in these module builder. You subclass module. So that means that class and instances of this class are modules. And then you have initialize method in there, and then in the initializer you can configure this thing, which means you can configure the module. And then there you can define methods in the initialize method itself, or you can define methods in the included hook. And I think this is probably also kind of unintuitive, because normally when you see included, right, this hook method, in probably 99 or 100% of cases that you've probably ever seen, it's usually self.included. That's always the case we see. You self.included and then you do some stuff in a hook. But here this is an instance method. It's an instance method because it's an instance of the class big M module. So you kind of have to like meta your brain or something to kind of get this. It takes a bit. It's not actually complicated. It's just that it's not intuitive at first. And then what do we do with this thing, right? Once we have it, so we include it, but we don't include we include an instance of it. So in this case, we pass some things. In this case, title and content, and these are going to be the attribute names up here. We include an instance into our class post. So have I lost everybody? It's good. So like I said, the configuration, so this is the specification part that I was talking about. How do you configure this thing? It's really simple. It's just an initializer. So it's like any other class. You just put some configuration there. So that thing that I had in the early slide where I had this config and I wanted to stick it in the module, well, you can do it here, actually. And then you just include it. And the other part of this is encapsulation. So encapsulation, what are we using for encapsulation? We're using another sort of default Ruby feature. We're using a closure. So in the included hook here, I'm taking these names, and the name here is outside the scope of the method definition, right? So this name here is outside of this method. So I don't need to have some kind of private method or whatever. I use a closure, and then I can use that name from inside the defined method body. So make this a little more clear. Let's go back to this addable thing, right? So this was the example that I was showing you earlier. And actually, when you look at it now, right, it's really simple. So this actually is the solution here for module builder. I just subclass module, have an initializer, and then this here is exactly the same method. So that's exactly the same as what I had before. That's just defining a method plus, which adds things on all the accessors, on all the keys here, and the keys are right above, right there, right? So it's exactly the same thing, but it's shorter for one thing, right? So here you can see now we include adder builder. We include an instance of adder builder where we pass the amount in tax, and these could be anything, but we're passing amount in tax. And then you can have the line items, and you can add them, and there's no problem. And the nice thing here is that we don't have this bootstrap method, so we don't need to add a class method to the class to then create an anonymous module which has these methods on it. We just do it in one step, and we do it cleanly. And unlike the original or a normal module, we don't need to have private methods or anything like that. It's really clean. It's all encapsulated in its own thing. Oops. Oops. Oh. So and then it also does composition. So this should be kind of clear, but it's the same thing. Oops. Oh yeah. Sorry. So it's like this basically. Like when you include it, you're kind of it's not actually a module new, but I mean it's kind of like this. You're kind of creating an anonymous module, and you're doing that. So it's basically the same as the example with the adder includer that I showed you earlier. It's basically the same thing. So you can do composition, no problem. But the nice thing here actually is, unlike the anonymous module I showed you earlier, because this thing is a subclass of Big M module, right? It's actually an instance of a class. So if you go into the ancestors, you can see it, and it actually will show you, hey, I'm an adder builder. It won't show you just module, because if you just do anonymous modules, they all look the same, and it's really hard to figure out what's going on in this ancestors. But if you subclass them, they get a name, and so you can right away see what it is. And not only that, if you define an inspect method on them, you can show whatever you want for this thing, and you can make it really look really intuitive in there. So it's much easier to deal with in that sense too. Okay, so I'm going to try giving you just a few examples of what you can do with this thing. So first, I gave you that slide way earlier where I said, you know, to get a broader abstraction, you have to have a more expressive specification and tighter encapsulation. So here we're kind of flipping this upside down. The builder, it's more expressive because you can pass in whatever arguments you want to the initializer, and then you can build your module however you want from that. But it's also encapsulated, right? And that's different from the other ones that I showed you earlier. You don't need to add class methods on the class. You don't need to add any state on the class. You can just wrap it all up into this module. So you end up with something that can be a broader abstraction. So here's an example. Unfortunately, this is a lot of code, so that I had to shrink it to 6-point font. Is Matthew here? So this is actually an example from a gem called Alchemist. And I gave another talk about mobility recently, and I mentioned the module builder there. And somebody said, oh, like there's this gem called Alchemist, and it uses the module builder as well. And it was really interesting, actually, because I opened up just this class. And the class is actually called module builder. So the interesting thing is, if you look around at gems and stuff, and there's that example from Devise as well, there's a lot of gems out there that are trying to configure stuff somehow. They know that they need to have some way to configure a module, but they don't know, people don't really have a natural way of doing it, so they go to great lengths to do that. So in this case, what's happening is this is a class. This is not a subclass of module. This is just a normal class, and you got some configuration passed in initializer at the top there. I'm sure you can't read this, but it's not that important. But basically, as an initializer, you pass some configuration in, and then you do a bunch of stuff. And basically, what this thing does is you create an instance of it, and then from that instance, you call build module, and it builds you an anonymous module with some stuff on it, right? So I looked at this thing, and I said, okay, this has got to be refactorable. And so I refactored it with this subclass of module. And you can see, first of all, the length is about 30–40% shorter. But it's also actually much easier to read. So here you can see on the left side, there's a method that's building an anonymous module. That's what I said earlier, this module new, right? It's building an anonymous module, and then it's including that thing. But on the right, the whole thing is a subclass of capital module, so you don't need that. You just include the thing, right? So you save yourself a lot of kind of boilerplate, all this code that's also really hard to read. There's a lot of tricky metaprogramming stuff in here. You can't read that, but there's some kind of eval stuff going on in there. You don't need that stuff. You just subclass module, put some configuration, and define your methods, and you're done with it. So that was a kind of a really nice example. Not all the examples of this are that easy to refactor, but this one was. Another example. This is a gem called Dry Equalizer. It's one of the dry RB gems. And if you're interested in this idea and you're still having trouble getting your head around it, I highly recommend opening this gem and just looking at the code, because it's just one pretty short class called dry equalizer. And all it does is it's very similar to what I just showed you with Audible. Actually, when I wrote up Audible, I kind of looked at this and kind of used it as a reference point. But you pass in some keys. Here, this is a geolocation class, so you pass in latitude and longitude, and then you define your latitude and longitude on this class. And what the dry equalizer does is it defines all these hash method and compare method and all this kind of stuff, so that you can now compare instances of this thing based on the value of those at those reader, those accessor variables. So if you try this out and you create instances here, this is directly from the gem README. You have point A, point B, point C, and then you can kind of inspect, and you get a nice inspect method, but also you can compare them, and it'll have these compare methods find for you in terms of the values of those accessors. So it's kind of nice. And then, like I said, originally in this talk I was going to talk a lot about mobility, but I realized it's really too hard to kind of get into detail, so I just made one slide. But like I said, working on this gem was really the inspiration for getting into this whole idea. And like I said earlier, mobility kind of abstracts this idea of a backend, and the backend is kind of the thing that stores things for you, translations for you in the database. So you have a method read. And the part where, so I use module builders like all over this gem. Like it's probably more than half of the modules are created by module builders. But one of the ways I use them is that I want to have this flexible configuration where you can kind of include things or not include them and include them in different ways. And so what it does is it builds up this thing called a backend, and it kind of includes these different things, but it configures these things as it's loading the classes based on whatever you've passed in these arguments to this method translates. And translates is literally just becomes include a module builder itself. So it allows you to customize the translation accessors per attribute and add customization to models. So it was really useful there. So this is Thomas. I put this up here because I was really surprised when I wrote this blog post. Like I expected people to like pick on me because I was using this term builder, because it's one of these design patterns, and I thought, module builder, like maybe I should use factory or something else. And I thought people were going to attack me on this, and I had a whole defense ready for this, right? And nobody cared. Like nobody cared at all that I called it module builder. What people cared about was that I was using metaprogramming. People were like, you shouldn't, what, metaprogramming, you shouldn't have to do that. And to me, this is just totally nuts, right? Like metaprogramming is like the best thing about Ruby, in my opinion. And on top of that, you can't, so the kind of things that I'm doing here, it's actually a refactor of a metaprogramming thing. It's actually a really simple metaprogramming thing. So, don't be afraid. A module builder, it's just a subclass, right? That's all it is, it's a subclass of a class. It's just configuring an instance, which we all do every day, right? And it's just defining methods on a module. There's no magic here. And the interesting thing is, Mats talks about all these things with modules today, and he's talking about refinements, and he's talking about prepend and all this kind of stuff, right? But the stuff that's here, and I'd be curious to talk to a core Ruby committer who knows Ruby from way back when, but I'm pretty sure that what I've talked about today will work from almost the first version of Ruby. Like there's nothing special here at all, right? So most of all, the module builder, it's just plain old Ruby. And I emphasize old here, because it's really old. It's probably as old as module itself. So I encourage you to give it a shot, and thanks.
Do you have any question?
Sure. It's kind of specific, but in your examples of module builder, you were often including the module and then doing new on it and passing in some parameters. Whereas in your example with mobility, you have this translates keyword, and you're saying you're using that to then build a module.
Yeah.
So I'm just wondering why.
There's nothing. It's
Okay.
just because people are. I mean, actually, if you look at the dry RB, so actually, it's mostly just because people Rubyists find it confusing to include something that's an instance. Basically, that's the only reason. There's no, and it's shorter. It's a really stupid answer, but actually here too, right? I actually modified. This is from the README of dry equalizer, but dry equalizer, what they do is they take away the new and they just define a method equalizer, capital E equalizer on the module dry, so you don't need that new there. And I changed it because I wanted to make sure it was clear what this was doing. But the reason I think they do that is because people find it unintuitive that you're including an instance of something because you never do that. So there's no technical reason. It's purely syntax sort of human thing, right? Yeah.
Do you have any question? About 5 minutes left, so
Well, thank you very much
日本語でも大丈夫です。
for the good speech. I'm a tech writer, and I saw, I listened to your speech, and just briefly take a look at your article, closely related to this, introduced on your profile. And if you're okay, this is not the question, but just a small request that if you're okay, I'd like to translate this article into Japanese and publish on a tech blog.
Oh, sure. Yeah, absolutely. Thank you.
Yeah, thank you very much for your permission.
I love these questions. Anybody else want to translate it? Oh, yeah, そう、日本語でも大丈夫です。すみません。なんか見ないすみません。言えばよかったです。日本語でも大丈夫なので。
すみません。じゃあ日本語でカプセル化パラメータを取らないようなモジュールでもカプセル化のメリットを取るためにこういうモジュラパターンを使うっていうのはいいアイディアだと
コンフィギュレーションがない場合ってことですか？コンフィギュレーションがなければ、まあコンフィギュレーションがなければモジュールだからアノマスモジュールと同じ。多分一つだけは名前がついちゃうということですけど、まあそのぐらいだと思います。コンフィギュレーションがなければだからなんか大文字のなんかクラスコンスタントイコールモジュールニューだったら一緒だから、そのぐらいは意味あると思うけど、それでもアンセスト見ればわかる。でもまあコンフィギュレーションなければそんなにベネフィットはないわけですね。
ありがとうございます。
Oh, sorry. So what he was asking is, if you don't have any configuration, is there any benefits to using this? So you don't have in the examples, I always pass in some arguments in the initializer, so that allows you to configure the thing. But what if you don't have any configuration? And my answer was that there aren't that many benefits at that point because you're not really changing your module. The only thing that I might say is that if you define constant, you like define module new and you assign it to a constant, then in your ancestors you can see that. That's the only thing I can think of. But obviously the real benefit from this comes from being able to template things with some kind of flexible variables in there. So.
do you have any question? It will be the last question.
You got it in videos, huh?
So, can I finish this session if you don't have any question? Okay. Thank you very much.
Welcome.